The next person I would present is a role model for Ethiopians. In fact, as I mentioned, there's this exode of intellectual people. There is this exode of young and bright Ethiopians going out of the country to make it abroad, and now that are coming back to participate in the Ethiopian Renaissance. As a matter of fact, it's not only the GERD, it's the whole country that is being birthed again to find its new narrative. Dr. Rousseau Asafa. Dr. Rousseau Asafa, like you mentioned also, Professor Haggai, is, I think, in my view, someone who is in divine appointment. When you are at the right place, at the right time, with the right people. And I would like to thank your participation in the GERD Dam on how to knowledgeably and professionally communicate what the GERD is all about and the impact that it would bring in the world. So Dr. Rousseau is a registered professional engineer with the state of Florida, and he's also a diplomat of the American Academy of Water Resources Engineers and fellow of the American Society of Civil Engineers. Rousseau has written over 40 peer-reviewed articles in various areas of water resource management. He is the recipient of the 2022 Outstanding Practitioner in Water Resources Award by American Academy of Water Resources Engineers. And Rousseau is currently, he chairs the Florida Water and Climate Alliance Group. Dr. Rousseau is also the founding member of We Aspire, a group of volunteers and professionals who, like I said, would knowledgeably introduce and present Ethiopia and its narrative as it is. Dr. Rousseau, you have the floor. I leave you the mic. Thank you very much.
Thank you. Can you hear me?
Yes, we do. We hear you loud and clear.
Yeah, okay. Thank you. This is great to be invited. Thank you very much. I really appreciate. Thanks for that generous introduction, Hermila, as well. I'm actually a little bit late. I came. I'm not the founding, almost, but later on I joined this great group with We Aspire. It's an honor for me to share this webinar with great historian like Professor Eldik. I think I learned a lot today. And also His Excellency Ambassador Henok, that he put it nicely, not just what I'm going to talk from climate change perspective, that all around how GERD maybe, it's a great example for other places, not Africa, but in the world as well. He touched both from mitigation and adaptation perspective. When we talk about climate, we typically say mitigation, that is an effort to reduce the carbon emission. Adaptation is typically if countries don't agree, and how do we adapt what we'll see. Today, I will focus more on that one, on the adaptation side as well. A few slides, maybe 7 or so slides, and I want to make sure this is not a typical presentation I do with this kind of diverse audience, but you hear quite a lot about climate change, how it's impacting the entire world today. It's amazing. If in the US in the last, let's say, 5 weeks, we have 5 events that are supposed to come once in 1,000 year. So once in 1,000 year event means the chance of getting them in a year is about 0.1%. We just got 5 of them in the United States. In Europe, the same thing. Heat waves, some even in France, where the ambassador is as well, some river drying in China. And if you go to the East Africa, there's a lot of flood now in Sudan as well. So it is clear to me that you can see some of the impact of this climate change, and it's amazing if you just Google, some of the news, you will see quite a bit these days. So it's not unexpected, but things are getting really even dicey, and that's where infrastructure like GERD, even means a lot going forward. So just to give you a perspective, I will touch a little bit, not too much, but a little bit of the science, what we are talking about, and then come back, circle back to GERD as well. So we talked, when we typically hear, oh, climate change is impacting us, oh, it's going to make us dry, or it's going to create flood. What exactly means? How do we get this information, and how exactly impact us, and how GERD contribution plays into this big picture of climate change? That's where I'm going to focus today. So a short, very elevator speech about climate models. We use what we call general circulation models. So these are models that typically are run for the entire world, representing the physical process of atmosphere, ocean, cryosphere, and the surface. And they are done typically at a much coarser scale. So this is the most advanced, models or tools that we have today. But as I will show later on, and there is implication on what we hear from the news and how this is translated on how politicians play this as well. They are typically about 200 kilometers. So you can see on the right side, you see a picture going up all the way to the atmosphere. Sometimes you have these 30 layers. So this is the physics. The climate scientist will solve these physics given what happened in terms of emission of greenhouse gas emission, including carbon dioxide. Now, some of the issue with this is that because they are very coarse and high area, they low resolution, basically, for hydrologists like me or for water resources engineers, trying to figure out, okay, how much water is going to get in the future, how much it changed. Professor Erlich earlier said about the flow, whether it's going to change in a few years and so on. I have some results as well, but that's how we figure out, based on these models, we try to figure out what would be the future. And most of this process, including how cloud and other processes, they happen in a very small scale. So there is this uncertainty when we bring into a local level decision making. That's another uncertainty. So how does climate change actually impact us? So when we say we are getting impact from climate change, we typically means that the statistics, typically how, for example, temperature, it has been in the past and what's going to happen in the future. So the one you see in the top could be changing or shifting the mean. So in this case, you will get more heat and less of the extreme cold. That's what we seems to be right now. We have more of those. So you have this bell shape. Typically you have, okay, for a few months I have an average, and then few months very cold and other months hot. So it shifts the entire distribution of that, how the temperature is. Another could be is it changed the variability. So in this case, it just stretch this bell curve, and we get more extremes of hot or cold, and the same thing for rainfall. That's another way that's impacting us, specifically within the Nile Basin and everywhere else as well. Or it can change the symmetry as I show here. Now, most of the predictions and people, when they say this is what's going to happen in the future, there is some uncertainties. The reason I'm going through this is you may hear one newspaper saying this, one saying that, one research says this. It is important to look at the consensus of many climate models, how they see the future, because an individual model is not going to give you a good view of what would happen 20 years, 30 years in the future. As you can imagine, forecasting next year is very difficult, let alone forecasting 20 years, 30 years from now. So the first issue is climate by itself is chaotic, as we say, and that's sensitivity for the beginning. So a small shift results in a huge consequences. That's one. The second is that we don't know exactly how sensitive is the climate. And I will give you an example. For example, 10 years ago or so, the prior generation of climate models and what we have today, we call them high resolution, are actually very different. the new generation of models, most scientists say they are more sensitive, and we are seeing more warming of the climate or our world than we thought before. This is important because that if you depend on in stream flows or other aspect of the hydrology, even in healthcare, that we are getting now hotter than before. So that's the second issue. So we don't know how exactly it is. What we know is changing and it's getting even more sensitive. And the other is our ability itself to model at a local scale, because we want to make a decision within Nile Basin, but we are solving the entire world problem. Literally, from physics perspective, that's not an easy. The other, number four, I think Ambassador mentioned this too, and you all remember the Paris Agreement, is we don't know exactly how the future emission would look like. We can only say if X happen, what's going to be the result? If Y is going to happen, what's going to be the result? So we really don't know what would be the emission. There is a wish list. We can cut to 1.2, 1.5. You heard from the ambassadors talk as well. But that has a consequence in terms of investment to limit what would be the total emission into the world. So because of that, we really don't know. We can only say if people agree and follow up what they did, what they say they would in the Paris Agreement, that will be the case. So if we look at it, so we call the first one is a natural. So it's more, we can't do too much about this. And the second is scientific uncertainty. We are learning more. As I said, the new generation models that I will show later on, what it says for Africa, what it says for Nile Basin. We call the CMAP6, the high resolution. We just got this year in terms of the IPCC report. It's a little bit different from what was the prior generation. So that's a scientific uncertainty. Then you have this human uncertainty, as well as on how the heads of states of the world, how they decide on tackling, limiting on these emissions, which, as I said, there's implication for investment. Coming back now, I'm zooming into the Nile Basin. I actually looked at about this 3 years ago, and I looked at hundreds of climate models, and I say the output, and I say, what do they say for the entire basin? Collectively, this is more than 100. I don't think you will be able to see on the right side. You see different areas: Lake Victoria, Victoria Lake, Lake Albert, and so on. So you can see these are the different big basins within the Nile Basin that you see on the right side. Collectively, all of them are saying the temperature is going to increase. There's no question about that. But when you talk about the rainfall, some of them, they say it increased by this much. Some of them, it increased by that much. Intensity increases by this much. Now we have to figure out how to summarize this. And that's exactly what the intergovernmental panel of experts, typically is called the IPCC, summarized and say what's going to happen within the Nile Basin. And that's what I'm going to show you. You can find this report online, by the way. So some of the high level, and again, there is different. The reason I went through some of the uncertainties, some of the challenge, is because you may see different result in a smaller scale, a different place in Nile Basin. But collectively, what they see is that there will be an intensification of future annual rainfall by about 25% in the Eastern Nile Basin. So basically Ethiopian highland, and then you have Sudan and Egypt. Basically, that's the region of the Eastern. So the rainfall is from the highland of Ethiopia. And then you have 5 to 10% increase in Lake Victoria. So intensification means is that you get more rain in a shorter period of time. So basically, so that means you are prone to flash flood types. And then up to 15% increase in a wet season. So this is important when you look at the Nile within the Blue Nile, and then a decrease 24% in dry season. It looks like, okay, you have increased 15%, you are decreasing 24%. But this overall actually implies a little bit of actually more increase in terms of the flow, because we get most of the flows during the wet season. In the Blue Nile, we get it almost in 3 to 4 months within the basin. There is increase in precipitation in wet seasons in Ethiopia as well, and it indicates a significant increase for flash floods without storing it the dam. So building a dam, not just GERD, but building other dams will help us to mitigate these flash flood issues. A decreased runoff in dry season could result in shortage for irrigation for Sudan. Hello, but this conclusion are before GERD. So that means if you don't have any storage, that something like GERD, that typically it's expected the climate change would impact them because it shifts the variability. It brings more the wet season, which they cannot hold. It will be a lot of flood. And then dry season, if they need it to irrigate, they don't have the water. Annual flow revenue, and they check this, actually increases within the Blue Nile, and also Khartoum are projected to increase. So this is consensus. The reason I'm saying is you may find 100 studies, but what the IPCC basically does is that they try to summarize based on these many studies and all these uncertainties in a way that most people would agree. And also they give it some confidence. I'm one of the writers for the National Climate Assessment here in the United States. And there is a way when we say, okay, I'm confident, credibility. So there is a percentage we associate about the probability of something happening. So this is the consensus from the IPCC, basically. So where does GERD fits here? Well, you heard earlier, power generation is big for Ethiopia, and then for us, Eastern Africa as well. As Ethiopia grows into it, as you can imagine, we have two of the turbines ready at 375 each. If you go to talk to the engineers, you will see that even though they may produce high, it depends on demand, the time, and so on. So as Ethiopia grows into this capacity of GERD, there's definitely opportunity to export as well, because we don't have the infrastructure already there. Irrigation, industrial expansion, electricity, obviously, flood protection. Flood protection is huge. Probably you remember on what happened in 2020, and I wrote an article here you can find in the We Aspire website that for the Sudan, I literally said that the Grand Ethiopian Renaissance Dam is a matter of life or days. 2020 was exception in a way that we got almost a once in 100 year event and made a lot of destruction. So that's huge. So that probably will not happen going forward, that kind of devastation. It increased the storage by about 50% to Egypt and 500% for Sudan. And it is an insurance basically for going forward into what climate change brings from the in terms of variability. There is some studies, this is from actually by Egyptian and Sudanese folks, where we are today. This is where we are, the total storage in the Eastern Basin, and we need this much based on if history repeats in the future. We know history is not going to repeat in the future, and we probably need much more storage. So while GERD is great, we still need more storage than GERD to actually weather this amazing variability in terms of the rainfall and change in temperature that we see within the Eastern Nile Basin. The other things, I took this slide from, I like this, Dr. Khalid. This is one of our partners through the what's called the Friends. If you haven't attended that, that's one of professionals we meet almost every month, and we met for the last 24 or so months. And one of their studies shows in terms of the benefit of the GERD, and they look at intensification of agriculture, electricity, all these, what would be the benefit for Sudan. And what they found is amazing, about $1 to $2 billion of GDP growth for the next 40, 50 years. And one of my favorites is actually how does it impact for rural household? That's the number you see, 21 to 37 billion. So the GERD benefit not only, and this is directly countering the climate change, by the way, because they wouldn't be able to do this if the GERD was not be there, and given the projection that I just showed you from IPCC. In terms of the conclusion, I will just say climate change impacts are going to be worse, and we know that because the level of emission has not been decreasing at all. So many countries they did pledge to decrease their emission, and again that's really gets into investment. As far as I can see, as far as many people they see, there isn't really a big reduction on those emissions. I guess it's better to prepare for the worst case scenario, which is business as usual, unless there must be huge investment. One of the things I want to mention is Africa's contribution on this emission is minute, but the impact you look at in Africa is significant. So who's going to bear this cost? That's another issue people need to figure out. Infrastructure investment like GERD addresses both mitigation and adaptation. So when I say mitigation, it's basically a clean energy, much less greenhouse gas emission, which is the catalyst for changing our climate. The reason for this is very simple. The physics tell us when things warm up, they tend to hold a lot of moisture than otherwise. So that lot of moisture has to somewhere go down as a rain. So that means you have more rain coming in down. So it simply shifts by physics. It's not gonna, energy doesn't disappear. So it's just moving around places to place. So it dries up some place, takes a lot of water. Because it's warmed up, it can carry a lot of rain. And then when it condensates, you have floods. United States is a perfect example this summer. I mean, we have been dry here in Florida this summer like I have never seen. July, August, typically we shouldn't use our reservoir. We are using that. And then you have flood in many places that I mentioned, for example, 5 floods in 5 weeks that are once in 100 years, 1,000 years. Other mitigation strategies are important as well, not just GERD. But such as, the green legacy is important one. I think Ethiopia, this one thing commendable they are doing is, it means that it changed the climate, local climate, but it's not enough. If you are doing it only on a small scale, that's not gonna make a big difference from the world perspective. It'll make a difference for Ethiopia as well in other areas, including, for silt reduction, as well as increasing the local rainfall. There is studies here. I can give you an example here. I live in Florida, Tampa. We have more than 100 years of record in rainfall. And the airport, there is a gauge where we measure the rainfall in the airport. Because of all the asphalt and concrete, local heat island, it has statistically significant lower rainfall than any the other station that we have within few miles. We have many of them. Each of them, they have more than 100 years of record. So it's clear for us, and there are many studies that shows that putting a green space increased rainfall. I think that's all I have, and happy to take any question. Thank you.